Hi, my name is Skipper Chung Warson, and I'm a coach and design director in San Francisco, California. Welcome to the second season of How This Works. This is a show where I talk to people about topics in which they are experts. And today, Zolt Levay talks to us about his work as a nature photographer, both out in space and in our terrestrial world here on Earth. Thanks for making time to be here, Zolt.
Oh, it's my pleasure, Skipper. Thanks for asking me.
Of course. So let's dig in, and specifically, let's start with pronouns. My pronouns are he and him. How would you like to be referred?
He and him.
Great. Let's talk more about you. Let's start with you. Would you introduce yourself in a few sentences?
Sure, Zolt Levay. I guess I've had passions about photography and astronomy for quite a while, ever since I was pretty young.
Okay.
And so I kind of ended up getting some education in astronomy, a formal education in astronomy.
Okay.
And went on in a career in mostly with the Hubble Space Telescope mission, NASA's Hubble mission.
Okay.
And I did produced a lot of images for the Hubble mission. Along the way, I did a lot of photography, personal photography. I sort of self-taught in photography, but I've been doing it for a long time and enjoy it quite a bit. And I've explored various things and various avenues of photography. You know, that's kind of what I do. Have a lot of interests, other passions, have a family, have a wife, 2 kids, 2 grown kids.
So what's something that people might not guess about you from the surface and from reading your biography? Is there something that comes to mind, something, of course, that you would be comfortable sharing?
Well, one is that I wasn't born in this country, although I spent except for 4 years of my life in this country. My background is my parents were from Hungary.
Okay.
Left during the Second World War. Those upheavals in Europe were devastating to many, many families, my family among them.
Mm-hmm.
And they ended up getting relocated to Pakistan, of all places. And that's where I happened to be born.
Oh, that's interesting. Have you been back to either Hungary or Pakistan?
I've not been back to Pakistan, although I'd like to, although this may not be the best time
Right.
to visit that part of the world.
Sure.
I have been to Hungary one time and enjoyed it very much. It's an interesting place, interesting country, distinct in many ways, as most European countries are distinct in their own ways.
Mm-hmm.
I enjoyed it. I enjoyed my very brief visit very much. I have one fairly close relative still alive in Hungary.
Okay. I wonder, when visiting Hungary, did you feel any sort of connection? Some people talk about when they return to, and I realize that you weren't born there necessarily, but as the homeland of your parents, is that someplace that, did you feel connected there?
I did, actually. And, I think it's a cultural thing. You hear, family stories, family descriptions of places, of times, of cultural things. And yes, I did feel a very strong connection, actually. And I would very much like to go back. Again, the politics gets in the way of a lot of things.
Sure.
The politics in Hungary is rather interesting these days, shall we say.
Yeah.
But I did feel a strong connection.
Okay. So let's jump into our subject. What is this of how this works? I gave a little bit of it away in our introduction, but I'd like to hear you say it if you don't mind, Zolt. What are some of the subjects we're going to talk about today that you know very well?
First and foremost is producing images, and particularly producing images, astronomical images, and especially the images from the Hubble Space Telescope, which are arguably among the best astronomy images that we have available now until the James Webb Space Telescope, which equivalently wonderful and amazing.
Yeah.
So that's part of my expertise, and in the larger sense, photography, producing images, those are very intimately connected. So I see it as a continuum, photography, whether it's standard photography that most people might be familiar with, extending into producing images, astronomical images. It's photography. And and also the concept that what we're seeing in these photographs is nature, whether it's photographs of landscapes on Earth or photographs of places in the deep cosmos. It's all part of nature, and it's another continuum that we can experience, albeit with specialized instruments if we want to look at deep space objects. But I still have a strong connection with the natural world, and feel like it's important to study and appreciate.
That's a nice distinction, and yet sort of conglomeration that you just brought up. And I'd like to get into more of that later, how the photography that you worked on as a result of the data and all of the information that you received from the Hubble Space Telescope, it's still nature photography and still plays into your work that you do here on Earth as well. But before we get into that part of it, one thing that I want to ask, Zolt, is how did you get started in this work? The Hubble began to produce images, what was it, in 1990?
Correct.
And when did you start working with the Hubble data and information?
Well, I was on the project since 1983.
I see.
Since before launch. Now, I wasn't working, there was no data from the telescope at that time. We were preparing for the launch. I was doing software development. I was a programmer.
Okay.
And we were working on some software for the users of the telescope, the astronomers, to use to analyze their data.
I see.
So I had some experience with the data, with analyzing Hubble data, but I didn't really start working on the images until around the time of the servicing mission, which was in late 1993.
Okay.
They sent a shuttle mission up to service the telescope, to put in optics to correct the defect. The defect was in the primary mirror of the telescope.
Okay.
And they were able to put in some additional optics to correct for that defect. And so around that time, I joined what was then called the news office, which was established to disseminate the findings from the telescope. So the discoveries, science findings that were made through observations with the telescope. And Hubble was producing observations since launch. And part of the reason for establishing that news office which was kind of an extension of the NASA publicity department, specifically for Hubble, was to get that message out that Hubble actually was doing valid science, worthwhile science, even though it had this fundamental flaw.
Right.
But then around the time of the servicing mission, I joined that office, and partly because I was familiar with the data, and I was already at the institute, the office that I was at the Space Telescope Science Institute, which is the facility that is responsible for all the science operations for Hubble, planning the observations, archiving the data, making the data available to the scientists, and all kinds of functions. This is independent of NASA. It's actually funded by NASA, but it's operated by a consortium of universities that operates other observatories. So, but anyway, part of this institute is the public outreach office, and I joined that office again because I had some experience with the data, and I had this photography experience. So I kind of knew the paradigms, the procedures for producing images from the telescope.
Gotcha.
So fortunately, I mean, I just sort of fell into it. It's not like they say there. I always kind of marvel at the fact that there was no career path for this. Really, it just sort of developed, and I just happened to be at the right place at the right time, I guess.
You hinted at this a little bit in your introduction as well, but there's a reason why you were working with the data. You have an academic background in this field. How and why did you start there?
I guess it's kind of in the deep dark mists of the past, but I feel like ever since I was in say junior high school, I became into. I feel like I was always interested in technical stuff
Okay.
and figuring out how stuff works. And, taking things apart, making things,
Okay.
tinkering with things, and I also just a couple of trips to the west. I saw really nice dark skies, and I really kind of became in awe of the night sky, and
Mm.
that kind of I think pushed me in the direction of astronomy as opposed to maybe other directions like engineering or some other thing that I was interested in.
I see.
And so I just pursued this, the academics. I just always been kind of an interest, and I also feel like that astronomy is always been a visual science, right? It's
Mm-hmm.
always been
Mm-hmm.
based in the visual. Maybe not so much today. It's more data driven, analytical. It's more analytical today,
Mm-hmm.
but certainly the origins of astronomy are very visual. Looking at the night sky,
Yeah.
building instruments to improve our vision of the night sky. So, and I was always interested in those things. I'm interested in building telescopes, interested in photographing the night sky with my telescopes. And so
Mm.
it just all kind of worked together, the photography aspects of it and the science aspects of it. And it ended up that I wasn't quite so interested in the science per se and the analysis and the research,
Mm-hmm.
but I was always interested in the mechanics of it,
Mm.
and kind of I hate to use the word romance in a sense, but there is some romance involved in it. So yeah, that's kind of, I'm not sure that explains it entirely, but that's the history.
Well, I think that gives a little bit of insight. It may not explain it 100%, but I think it gives us a little bit of a peek behind what you remember and what you have capitalized in that interest. I wonder, you also talked about having a family, being married, and having two grown kids. Is this if I had to boil it down, I might summarize it as being led by curiosity. Is this something that's been a larger life philosophy for you, both as a father, as a husband, as a human in the world?
Oh, absolutely. Curiosity and yeah, interest. Again, tinkering with stuff, physical as well as mental, and
Yeah.
those things very much go together. So when you're planning something to say do some astrophotography, there's a lot of thinking and a lot of planning involved in that,
Yeah.
timing and working with the mechanical stuff, the
Mm-hmm.
instruments.
Mm-hmm.
So it all kind of fits together. I'm maybe not as good at that in the interpersonal stuff as I
Sure.
am with the instrumentation. Yeah, it's certainly I feel like I have a low level of curiosity about a lot of things.
Sure. Well, let's get into some of the nitty gritty of the Hubble, if you don't mind. And we didn't talk about this in our prep conversation. However, in digging in and learning a touch more, just so I can understand some of the bare bones of how the Hubble worked, I didn't realize this in all the years that I've ever heard about the Hubble, but the images that are produced from the telescope are in black and white. So when you look at some of the images, and there are some really spectacular ones. I think there's one, is it called Pillars of Creation? I think that's one of
Mm-hmm.
the best known of the images. How do they end up in color?
Yeah, that was the bulk of my work, or the nub of my work. So yes, the cameras in the telescope,
Okay.
they work pretty much like cameras that most people are familiar with the big exception that they do not automatically produce color pictures.
Okay.
What a lot of people may not realize is that all cameras today also actually operate by they actually operate by taking essentially three different pictures in three
Mm,
different colors.
mm,
So the camera sensors have little filters on them. So basically, they're separate picture elements within the sensor that record either green light, blue light, or red light.
mm-hmm,
And then the electronics in the camera, this is digital cameras,
Mm-hmm.
Film cameras kind of work the same way, but totally different technology. But
Yep.
digital camera, there's electronics within the camera that then puts that information together as a color image.
Mm-hmm.
And in fact, that's very analogous to the way our eyes work. Our eyes
Mm-hmm.
have separate sensors for red light, green light, and blue light. And then our brain actually puts those together into what we perceive as a color image.
Mm-hmm.
But on Hubble, and all astronomical telescopes work this way, professional astronomical telescopes, is that the cameras do not produce the color images. The astronomers are interested in the brightness of the light that's coming to us from space. The objects produce light in a multitude of colors, actually most of which we cannot even perceive because it's outside the range of what our eyes can perceive in terms of color, in terms of energy of light.
Okay.
But the cameras include filters which record a certain color of light. Color is related to the energy of the light. So redder light is lower energy, bluer light is higher energy. So what the astronomers are really interested in is picking apart those energies of the light and understanding how those objects are creating these various energies or colors of light. And so the cameras will record a particular color or range of colors.
Mm-hmm.
And then because of the nature of digital, the way we produce digital color in a digital environment, we can reproduce a color image from that data, from that information.
Mm-hmm.
And that's what we do. So the telescope will take a picture in, say, red light, the same picture in green light, and the same picture in blue light.
Mm-hmm.
And we've got 3 separate images. They can be displayed as a grayscale, a monochrome image, a black and white image.
Yep.
And then we can use just standard off-the-shelf software like Photoshop, for example, and reconstruct a color image from that.
Okay.
Because all the tools are available in just this off-the-shelf software to do that process outside of a camera. So the cameras, our cameras in our phones, separate cameras, all do that automatically.
Got it.
But with these data, we have to do it manually.
So the telescope, professional astronomical telescopes, take pictures, and I know Photoshop, so I can speak a little bit of this language. I know that you can split images into different channels depending on how you set the image up. Is it? And I'm calling back upon my university physics. Would it be accurate to say that these are the wavelengths of those colors, the red, green, blue, the RGB?
Correct. Yeah,
okay.
The wavelength is related to the color and related to the energy.
Okay.
So again, red light is lower energy, has longer wavelength.
Okay.
Blue light is higher energy, has shorter wavelength.
Okay.
So yes, astronomers will pick the type of light they want based on the wavelength. And so it's either a very specific wavelength, like light emitted by hydrogen in these objects out in space produces light of a very specific red wavelength.
Okay.
Although, on the other hand, an object like the sun produces light across the whole spectrum. So it's white light. It's composed of light of all the colors.
Got it.
And it looks white to us.
Right.
Because that light is spread across the whole spectrum.
Then there's some amount of interpretation that you have to do as someone who's processing the images to say, this is the blue light, this is the green light, this is the red light, and this is how this image would look to our eyes if we were able to look at it.
Yes, there's a lot of objective ways of producing it, and then there's some subjectivity in how you translate each individual image into a color channel.
Yeah.
But it's not arbitrarily subjective. It's based on how those images relate to each other and what we think it ought to look like. So, for example, certain objects are maybe predominantly red because we know they're producing a lot of red light. Other objects may be predominantly blue because they're higher energy. We know they're producing a lot more blue light. So in the final image, we can kind of have an educated guess as to what that image should look like, even though there's no way our eyes can actually see that to have ground truth.
Sure.
But we've seen enough similar objects that we kind of have an idea of what we would like them to look like or what we think they should look like.
Yeah.
And, it sounds kind of arbitrary, but it's actually less subjective than you might think.
Okay.
In a lot of cases, the image kind of just drops out of the data with a kind of a standard processing workflow. Other times it's a lot different depending on the selection of filters and the type of object you're looking at.
Sure.
In that case, the images don't really look like what our eyes would perceive given equal conditions.
Yeah.
Like if we could look through the telescope, for example.
Sure.
Because our eyes work very differently from the cameras are set up to work very differently from the way our eyes work.
Yeah. One other detail that I didn't know before I started researching, digging into a little bit more about how the Hubble worked, is exactly the power of this particular telescope. I read somewhere, and please correct me if this is not the right way to think about it, but at any given time, one of the images that the Hubble could pull was as though you held up a pin to the night sky, and that would be the area in which the telescope could focus in on.
Yeah, it has to do with the field of view that it can see at any one time. And yes,
Yeah.
I think the usual analogy is a soda straw. If you hold up a straw to your eye,
Okay.
and the part of the sky you can see through that straw is roughly what Hubble's field of view is. So it would take, I believe it's 24 million of those fields to cover the whole sky.
Wow.
So if you had enough time with the telescope, you could cover the whole sky, but it would take you 24 million images to do that.
Wow.
And plus it's also the sensitivity. So our eyes, it's so I don't know what the factor is, but it's some millions of times more sensitive than our eyes are because our eyes have a pupil that's, a fraction of an inch, but the telescope is 94 inches across.
Okay.
And that it can collect that much more light.
That is, I don't even know that I can fathom. That is hard for me to
it's hard
grok.
to get your head around it. Yeah.
Yeah. So to get back into the process of making the images, bringing them into color and, in a way that we can look at it as human beings, how much time did this take to work through these images?
It varies a lot depending on the data. It can be as little as an hour. It can be as much as weeks.
Okay.
and it's post processing. So
Yeah.
You can spend an infinite amount of time working on something on an image that's at once it's technological, but it's also there's a creative aspect to it. Like I mentioned, there's a subjective aspect to it, and then there's things like there are artifacts. The cameras introduce things that really aren't there in the thing we're looking at, right? So you kind of want to take those out, just like you might want to take out a dust spot that's on the sensor of your camera. You're gonna take that out if you're making a picture to put on your wall. So things like that. That takes some of that's pretty tedious. That takes a lot of time.
Right.
Now, I wasn't the only one doing this. So we had other. I worked with a team and a small team. People come and go, and there's other people around the world doing this. There was a team in Europe doing this. European Space Agency is the equivalent to our NASA, and they maybe not as big, but they had a small office for doing Hubble outreach also.
Okay.
So there were people over there doing it. So I wasn't the only one by any means. But it varied a lot, and depending on how much extra post-processing effort you had to do, really.
I see.
And there's experience. So, if you've never seen data like this, if you've never seen Hubble data, there's gotchas and there's things that you just need to learn. And like with everything, anything technological or anything that's complicated,
Did you have a particular image or maybe a series of images that seem to follow you around? In that, I mean, we end up having these, what Herman Melville called, Moby Dick, the white whale. So did you
Yeah.
have a kind of like white whale image that you were like, oh, I don't think this is quite right yet? Or one of the ones that took like weeks or, some extended period of time?
Yeah, there were certainly a few like that. And one I, that took a lot of time was
Mm-hmm.
something called the Carina Nebula mosaic. This is a region of our Milky Way. So our Milky
Okay.
Way is a galaxy. It's got a lot of gas and dust and billions of stars, as Carl Sagan liked to say. This is an area that's only visible in the southern hemisphere, but
Okay.
Hubble can look anywhere in the sky. It's not limited
Okay.
by our location on Earth, fortunately.
Okay.
So this place called the Carina Nebula, the constellation Carina, very dynamic area of the Milky Way. Stars
Okay.
are being formed out of this gas and dust. And so there was an observation that was like 50 of these little patches, little soda straw patches across the sky
Okay.
in a panoramic mosaic
Okay.
across this just amazing region of space. The catch was that it was only in one of these wavelengths. It was only in the light of hydrogen. So it was a
Oh,
black and white image.
okay.
But we put together this black and white image, nice, beautiful panorama. And then I sort of had a brainwave that this same astronomer who proposed to take these data, who observed these data, also used a telescope on the ground in
Hmm.
Chile
Hmm.
to look at the same region of space.
Okay.
But he did it, in that case, he did it in three colors.
Okay.
So in the light of hydrogen, sulfur, and oxygen, which are
Okay.
three different wavelengths that these places in space are emitting light, very strong, lots of light in these three colors.
Okay.
And so we also put together a color image. Now the ground-based data is lower resolution because Hubble's
Mm-hmm.
above the atmosphere.
Mm-hmm.
It's got better resolution. It
Mm-hmm.
doesn't have the atmosphere distorting the starlight.
Yep.
But again, kind of because of a trick of the way digital images work, you can separate the brightness data from the color information in an image.
Okay.
So we use the brightness information from the Hubble data
Okay.
and combine that with the color information from the ground-based data.
Okay.
And again, the way our eyes work, we're not so worried about the resolution and the color that we see, but our eyes are better at resolving the brightness information.
Hmm.
So this works to our benefit in this case. So when we
Okay.
put that together, we preserved all the resolution from the Hubble image, but we were
Mm-hmm.
able to add color to that from the ground-based data.
Oh, wow.
So, I thought, and I wasn't sure if this was going to work at all, but it turned out that it worked very well.
Okay.
I tried it with some other images subsequently, it didn't work as well. So it was very fortunate this particular image worked very well.
So it's
Now,
just
it's
a
not the
matter.
same as if you were to take all those different colors with Hubble.
Yeah.
And we did something like that later, but that's, but anyway, so because of all these reasons, because it took so much time and it was a fascinating region of space, that's actually one of the favorite images that I was able to produce.
Got it.
I'm very gratified that it worked out the way it worked out.
So different astronomers, whoever was observing this part, they could order certain data to be captured.
Yes. So
Okay.
astronomers propose to use the telescope.
Okay.
They want to answer some question, right?
Okay.
What is this object we're looking at? What is it? How is it working? What's it doing? Right? And so they write this very complicated proposal to use a telescope because the telescope is very expensive to operate. It's in high demand. Lots of people want to use it.
Right.
In fact, it's oversubscribed by some factor of 10 or something every year. And then that proposal gets reviewed by other astronomers.
Okay.
So people at the Institute, science operations people, but also independent astronomers will review these proposals and figure out which ones are the best ones to do.
Right.
And so then they specify what object they're going to look at, what instrument they're going to use, what filters they're going to use, all the specifications about how to do that. And then the telescope goes off and does it. They basically write a program that gets uploaded to the telescope. The telescope operates pretty much automatically and sends the data back down. And then the astronomers get the data.
Okay. I think we could talk about the Hubble and like your work there and like how it all works. I think we could just keep going on there. But I also want to switch gears a little bit because that's not the only work that you've done. You've continued to work as a photographer, and we'll drop a link to this in the show notes so people can go to it directly. But can you talk a little bit about how your experience working on Hubble images has both been, I mean, I guess it's a give and take because you were a photographer before you started working on the Hubble images, and now you continue to be a photographer after having worked on the Hubble images. How do those two philosophies and experiences inform each other?
Yeah, I think that's a good way of putting it, that they inform each other. So I certainly have used the experience I gained doing photography to help produce the astronomical images. And so, and not just the mechanics of it, but also the more aesthetic parts of it. Okay. So studying a lot of photographs, looking at a lot of photographs, following certain photographers it helps figure out how you adjust an image to make it, say, more powerful or more interesting to look at. There's so many ways to adjust nowadays, especially. And there were in the darkroom, but now it's a lot easier and a lot more convenient and a lot more avenues to make adjustments to an image. And so, I think that experience was very helpful in understanding what to look for in an image. What is it about this image that I can change to make it better, make it more interesting? So, one of the people my go-to kind of photography people is Ansel Adams. And he not only took a lot of photographs and was very famous for his photography, but he taught photography, he wrote books. And so I studied some of that and absorbed some of that. And I think that helped a lot. And I think the other way, too, it's a little harder to kind of think about that, but I think the mechanics of, how do pictures get put together? Well, when your camera's doing it, it's a lot different from when you've got to go a few steps back in the process and think about how these different color channels fit together. Sure. And so I think that can also inform the other side of photography, the more aesthetic side. So, yeah, it's certainly a give and take.
Yeah. Well, in your work on the Hubble images, data played a crucial role in how those images were processed, right? You wanted to see which wavelengths played out where, in what concentrations. How does data play in the nature photography that you're doing these days?
Yeah, it's not quite so direct, but sure. I think it does in a sense that you need to understand what your camera is doing. Mm-hmm. You need to understand, and this goes even back to film photography, and even more in some sense of film photography, because it was so much less automated. In fact, another, I keep bringing up Ansel Adams, but he taught about using all the resources you have available, all the control you have available to make the best possible final result. Mm-hmm. And so in his case, he wanted to make the kind of negative that would produce the best print. Mm-hmm. So he had to understand how to expose and process that negative, not to make the best looking negative, right, but to make the best possible print. And so he had to understand the process of producing the negative and the process of going from that negative to the print. And we have the same thing today with digital photography. We have raw images. The images are coming out of your camera, and taking that raw image and producing a final product, whether it's going to a computer display or going to a print. Yeah. And so the more you understand about how that raw image is produced, the better you are, because you can make a better raw image So you want to use the proper exposure. So
Sure.
you're not overexposing it or underexposing it. You want the
Right.
maximum amount of information in that raw image.
Right.
So you can extract all that information and produce your final product. So it's the same process. But yes, certainly the more you know about how your camera works, the controls that you have available,
Yeah.
and how to use those controls to produce your image,
Yeah.
the better off you are.
Yeah. When I was first talking to you about your photography, I naturally broke it into two different buckets. And I said, well, there's your Hubble photography, and then there's your nature photography. And one of the things that you pointed out to me was that it's all nature, that whether you're looking out into space or you're looking at something in a park or your backyard, it's all the natural world. Can you talk a little bit more about that and how for you that this is a overarching philosophy or an overarching notion as how you see nature?
It sort of came to me not that long ago that I saw connections between the images from Hubble and the
Mm-hmm.
images that I was producing,
Mm-hmm.
largely landscapes and outdoor stuff. And it was kind of funny because I was seeing similarities in composition and color.
Sure.
And even though the actual physical properties are vastly different, this distance scale, the scales, physical scales of these things are, you might be talking about miles in a landscape, whereas you're talking light years,
Sure.
billions and trillions of miles in a space image. And yet
Sure.
these structures might be visually similar. And in some cases, there's some physical similarities, right? Erosion processes and things like that.
Sure.
And so, I kind of broaden that realization to understanding that this is all, like you say, this is all nature.
Right.
Whether it's a nature that we can touch or see
Yep.
with our own eyes,
Yep.
or nature that has only been revealed to us by building these very sophisticated instruments to take photographs of things that are vastly far away and vastly beyond our personal experience. And yet it's all nature.
Yeah.
There's only one nature. There's only one world.
Sure.
Our little Earth here is just one teeny tiny part of that nature, and we're obviously intimately connected with it, and we should be.
Yeah.
But I think there's a connection with the broader universe also.
Yeah. I was thinking about as you were talking about this again, one of the ideas that fascinates me about any kind of space observation, let alone photography, is that because of the distances that we're dealing with, the thing that we're seeing is it's almost like time travel as we're looking out into the universe. And I suppose in a way, when we take a picture here on our planet, um, that it can also be time travel as we're capturing the natural world at the state where it is. My family recently, we went to a museum, and it was one of these natural history museums where there were many of these animal dioramas where you could see, some approximation of this animal in their natural world. And we walked by a number of exhibits where the animals were marked extinct. And I
Mm.
thought, well, number one, I'm glad that I can see what this animal might have looked like. And I'm glad that I could see how they might have functioned in the ecosystem and learned a little bit more. My daughter was fascinated. However, it saddened me to think that, this particular bird or this particular animal or these particular types of vegetation didn't exist anymore. And I suppose even in a way, photography on our planet can be a way of time travel.
Yeah, absolutely. Certainly, you're always capturing a slice of time.
Right.
And that's another thing I haven't explored as much as I would like, but the time domain is pretty interesting. And there's some things you can do. Obviously, motion pictures, you can extend that time slice.
Sure.
But even in still photography, you can take a time lapse and composite those images together, and whatever's changing will have an effect on that image. And I think that's an interesting thing to pursue. But yeah, you're absolutely right that our view of the world is always a snapshot. And we call them snapshots, but all photography is snapshots. And like you say, when we look farther out we look into space, the farther back in time we're looking, because light travels at a finite speed, and therefore farther away it is, the longer it took for that light to get to us. And that's one of the neat things about astronomy and astrophysics, that we can figure that out, that we're seeing things out in the universe as they were, not as they are today. It's a hard concept to wrap your head around. And then in the largest scales, it becomes totally unintuitive, because physics is doing really weird things at those very large scales, at those very high energies and high speeds. But yeah, the time element is fascinating, and our experience of, just like our experience of light is very limited. Our experience of time is very limited and very particular to our human experience. So, other animals might work on a much different time scale. Like I think about a hummingbird. I mean, their time scale is vastly different from ours. So, and then the historical, like you say, it's fascinating.
We've already been talking for a good chunk of time now, and I think that we could continue to talk. I feel like we're at a point in the conversation where we can start winding things up. So I'll ask you some of the questions that I ask a lot of the guests that come on the show. We've revised them slightly for the second season. So Zolt, what is one of the most important lessons that you've learned in your life so far, or in your work?
That's a yeah. I think I have to go back to this idea of the oneness of nature, and an appreciation for the world and for nature, and the fact that it's really, as we see our effect on nature, as incomprehensible as it might be, that humans can have such a vast influence on such a large thing as the whole planet Earth, of what we're doing. We have to be conscious of how we're interacting with the world, and we have to be conscious of the oneness of nature. It's a little frustrating because I personally have very little influence on that, but one can do what one can do, and but I think trying to instill in people that appreciation. That's one of the goals I've had in what I've done, both with Hubble's results and my personal photography, is to try to instill in people the wondrousness of nature, and the fact that we have some power to preserve it, to protect it, to conserve it, and we need to do that.
What's one thing that you're really excited about right now? And that can be something you're watching or listening to, or maybe something you're reading, something you can't put down.
Lately, I've been obsessed with astrophotography. So and that's, it's a complicated business. So I spent a lot of time recently trying to understand the universe of astrophotography. And it's a much bigger universe than actually I had thought before I really got into it as a personal thing, as a backyard astrophotographer.
Got it.
It's kind of an aside, but it's kind of an amazing time, because a lot of this equipment, the hardware and software, is just now available. Has been for a while, but accessible to people. I mean, in the past it was accessible, maybe only to professional astronomers, but now it's accessible to a lot of people. It's still very expensive, but so anyway, that's kind of my right now what I'm mostly obsessed about. I tend to, I pay attention to the news. I I try to keep up, but it it also takes me. It also is frustrating because I see so many things that I wish the world weren't that way, and
Yeah.
so I actually kind of cut down on my news consumption because I don't want to raise my blood pressure too much.
Yeah, there's a lot that's
But
happening.
in terms of my personal life, I guess it's the astrophotography that I've been most obsessed with.
If someone were interested in getting started in astrophotography, because I know it's not as simple as buying a telescope and holding your smartphone up to the telescope, is there a place? Is there a book? Is there some sort of resource that people should look to if they're interested in that?
Oh, there's lots of them, and obviously today there's a wealth of information on just about anything.
Sure.
Hard part is knowing what information to trust.
Yeah.
Certainly, a trusted source is a couple of. There used to be traditional magazines, but of course they have online presence today.
Okay.
Sky and Telescope is probably the premier, and I would probably go to Sky and Telescope.
Okay. Yeah, we'll check it and we'll put it in the show notes. Yep.
They have a lot of basic information, so how to choose a telescope, how to get into astrophotography, that kind of stuff. It's good.
Yeah.
As good a place to start as any.
Yeah.
I mean, there's a neat site that's called Cloudy Nights,
Okay.
and it's kind of mostly a forum for enthusiasts to share information and to ask questions.
Got it.
But it's much more as anything like that. It's much harder to find the information you're looking for. But
Right.
it's really actually a pretty good resource. The people on there tend to be really helpful rather than a lot of these kinds of things. There's people that just get off on some tangent or something. But
Yeah. Okay. We'll link to both of those. So if you had a day off, and I know you're semi-retired, and you could do anything, money was no object, you could be anywhere, you could conjure from your imagination, what would you do?
I'd probably go to a mountaintop somewhere, specifically a mountaintop observatory,
Okay.
like Mauna Kea in Hawaii or Cerro Tololo in Chile.
Okay.
I've been to Mauna Kea. It's a fascinating place, a tough place to get to. But just the ironic thing about those places is that visually it's harder to see the sky because the lack of oxygen. So at altitude, Mauna Kea is 14,000 feet, and at that altitude, the amount of oxygen in the air is much lower, and so your eyes don't work as well.
Okay.
But someplace like Kitt Peak, which is 9,000 or 10,000 feet in Arizona, that's a wonderful place. There's a whole collection of telescopes up there, and I've been there a few times. That's the one thing that I sort of regret not fully pursuing an astronomy degree, was that I didn't ever get to do that mountaintop observing at the big observatories.
I see.
And that's really what I wanted to do as an astronomer.
Right.
And now today, you don't need to go to. It's a lot. They're all operated mostly remotely.
I see.
So that's one of those romance things about astronomy: traveling to the mountaintop, some remote mountaintop, and doing your observing at the telescope. Doesn't happen so much anymore.
Got it.
But that's probably one of the. There's a million. I mean, I'd love to see the aurora. Go to Alaska or Yellowknife, Canada, which are great places to see the aurora. I've not done that, but there's a million things.
Yeah. Well, Zolt, where can people find out more about you? We've talked about your website, and we'll definitely link to it. Is there somewhere other than zoltlevay.com?
That's my website that I maintain. I'm not a very good maintainer, but I don't really keep it up like I would like to.
Sure.
But yeah, that's where it mostly is. I will point out that the work that I did and other people did for Hubble is all available at hubblesite.org.
Okay.
And now with webtelescope.org is the equivalent site for the James Webb Space Telescope, which I've done a little bit for James Webb, but there's a lot of good stuff coming out of there. But so certainly, Hubble site is a great resource if you want to see all the images and a lot of information about the telescope and the science that's coming out of the telescope. That's the best source for that.
Okay.
And I'm on Facebook, Flickr, Instagram, all the usual social media.
Nice. We'll link to them all appropriately, and people can find you at their heart's desire. Well, thank you again, Zolt, for taking time to have this conversation. During this conversation, my mind has been blown a few times, as I imagined it would be. Thanks for making time.
Well, it's been my pleasure. It's been a great conversation. I really appreciate it.
And thank you for listening to How This Works. We appreciate your support and would love it if you'd subscribe and leave a review wherever you get your podcasts. We're in our second season, and so many of you have already shared the show. But if you haven't, it would mean a lot if you could share the show with just one other person, highlighting why they should listen. You could find us online at howthisworks.show. It's 4 words with no dashes. Again, that's howthisworks.show. We're also active on various social media platforms. I hope you gained some valuable insights from today's conversation with Zolt. I certainly did. And with that, we'll talk again soon. And I've read in a couple of different places that, your full name is Zoltan, but you prefer to be called Zolt?
Yes.
Okay, great. So I'll just introduce you like that.
That's fine.
So Zolt Levay. Okay. And just to make sure, I think based on our previous conversation, am I pronouncing that right? Zolt Levay?
Correct.
Great.
Yeah,
okay.
The full name, I usually pronounce it Zoltan.
Okay.
That's the Hungarian pronunciation, but
Zoltan.
I don't use the Hungarian pronunciation of my last name. But
ooh, what's the Hungarian pronunciation?
Levay.
Levay. Oh, interesting. I can see how phonetically from American English that would not make much sense to a lot of folks.
Yeah, my parents thought that, and so they pronounce it the way they pronounce it. The way we pronounce it.
Okay.
Sounds French, but it's Hungarian.
Okay. That's really good background.